Welcome back to Data Architecture Day, sponsored by the Triangle Area SQL Server Users Group. So now we're going to hand it off to Joe Karlsson, who will talk to us about the wide world of MongoDB. Welcome in.
Yes. Hi. Awesome. Let's see. I must be live now. Oh, great. I can see myself on Twitch. Hi, everybody. All right. Cool. Let's see here. I guess I'll just get started, huh?
Sounds like a plan.
Oh. All right. Cool. I'll introduce myself in the talk and everything too, but great. Let's see here. Do I have to share my screen or anything? Yes.
Yes, and if you're using a Mac, you may have to restart the browser.
Yes, that's what it looks like. Give me 1 second. Let's see here. Looks like. Yep, just gotta get myself.
Everything is fine. Nobody panic. You're the one panicking. I'm not panicking. No, Joe will be back very soon. We found this with the last speaker as well, that if you're using a Mac, the permissions you have to grant require you to restart the browser in order for anything to display as far as sharing the screen. And welcome back.
Thank you. Thank you. Okay, I'm going to share my screen now and then we can get rolling here. Okay, cool. Let's see here. Can you see my screen? Looks like it should be up.
Yes, we can see it just fine.
Great. Everyone should be hearing my disembodied voice. And I'm going to be chatting about some fun stuff today. Okay, anyway, so you're here for MongoDB database design best practices. So I first just want to whet everyone's palate about why we're here today. But I want to talk about why is schema design in general, but especially with MongoDB, why is it so important, right? And it turns out that database schema design is one of the most important parts about improving performance and scalability of your database. This is regardless of the database you're using, right? This has been a huge part of RDBMSs and legacy SQL databases for decades, right? So we're doing normalization, and how much we're normalizing can affect performance of our database. Of course, there's other ways to do that with indexing, but database schema design is one of the most important tools we have for improving the performance and scalability of our database systems. So this shit's important. Okay, so who am I? First of all, my name is Joe Karlsson, and I am a developer advocate and software engineer, and I work for a little company called MongoDB. You can catch me on Twitter, Twitch, and this may be the first time anyone's seen this, but you can actually catch me also on TikTok. Hey, who knew? There's a couple of software engineers on there. I've been making funny videos on there for the last year, but if you want to check that out, that's great. Best way to get a hold of me, though, is via Twitter. So for sure, follow me over there. That's where I post all my interesting stuff. I'd love to get in touch with you, though. So one other thing. Opinions, they are of my own. Yeah, they're my own. So if I say anything like controversial or anything, please don't get me fired. It's me. I'm not speaking for my company here. I'm just like, I have strong opinions. I think it's important to share those in these types of conferences. Also, most importantly, is links. So if you want to catch links, there's a QR code in the upper right-hand corner of this slide. There's also a bit.ly link there, MongoDB Schema Design, as a link to all of the resources available here. I'm actually going to post these right in the chat. Let's see here. I can see the chat here too. I do not do TikTok dances. Hey, a lot of people do them. I make mostly software engineering jokes on there. Sometimes a dance, but not very much. Okay, let's get started. Enough about me. Let's get it rolling. What are we going to be talking about today? First of all, I want to be comparing relational versus MongoDB schema design approaches. So I think most of us are coming from a background with SQL and relational database design. And in my experience, most of the time I see developers approaching document database design as they would a relational database, which is a huge problem. but I think it's important to start there as our base point, right? So we'll be comparing those two. We'll be talking about the basic tenets of document-based database design, and that's embedding versus referencing, what they are and when you want to use each of them. Then we're going to be talking about a bunch of different relationship types, one-to-one, one-to-few, one-to-many, one-to-Squillions, and we'll be talking about different ways to do that. We'll also be getting into some advanced, I'd call it like, this is like a 101 type class for database schema design. We'll get into some 102 type stuff just to kind of get you to start thinking about how much creativity and flexibility you have with schema database design. So let's just jump in with relational versus MongoDB schema-based design. So most devs do not see a difference between these two. Like I said, this is literally the number one thing I see developers messing up when they come to MongoDB. Our instinct as developers, especially coming from SQL, is to normalize our data. So everyone wants to make a user table and a to-do table or whatever, right? Like you're separating all these different collections into separate things and doing joins in those data. That's not the best way to do that with MongoDB, right? You're not fully taking advantage of the document-based data structures for your project. And I'm going to say this so many times. You know what? I'm just going to say it here. It's with schema design, it's not a one-size-fits-all, right? It's like we have to figure out, based on your unique application, what is the best approach for designing that schema. That's what this is all about. That's what this is all about. And if Michael Scott sees you doing schema design like you would with a relational database design, he's going to freak out like this. And I will too. And like in a nice way, but we're going to yell. We're going to yell loudly at you, okay? Okay, so great. I want to first talk about relational schema-based design, right? Not everyone may be familiar with it, so I just want to give a quick primer about how we do relational schema designs with a traditional RDBMS. But when we do that, we are modeling our data independent of how we're actually using it, how we're actually doing updates and deletes and queries on that data. We're doing something, right? We're just, how devs do schema-based design for their databases with RDBMSs is they ask, what data do I have? And then you start splitting that data up based on what you have, right? I gave the example of that user table, right? But we do it through prescribed approaches that have been well documented, and it's called normalization. Typically, with an RDBMS or an SQL database, we're normalizing in a third form. There's up to 4 forms, right? You can normalize or denormalize based on how much your data needs, but typically this is the most average way that we do it. And that's just splitting things up and doing joins in them based on foreign keys. We do it so we don't repeat our human data, and it makes it easy for our human brains to understand what's going on with the data. If you don't know normalization, it gets really mathy really fast, but the TLDR, the massive oversimplification of what that means is we are splitting up data into tables so we don't duplicate that data. Not too bad, okay, right? We're just splitting it up so we don't duplicate the data. All right, so this is an example of a traditional or a legacy user table in an RDBMS. So we have our user table, our professions table, and our cars table. If you notice, each of those professions and cars table has a foreign key, which is the user ID, which we use to link up that data. I don't know how the hell we're actually using this. It doesn't matter, right? We have to follow these pre-prescribed approaches to splitting up our data. Okay, let's see here. I'm keeping an eye on the chat. If anyone has any questions, for sure reach those. For sure, you can ask those there. Otherwise, I will be available at the end of this talk to answer additional questions. I'm going to try my best to keep an eye on both. You may or may not know this, but it's hard to do both. But anyway, so normalization. Any question about that so far? But that's the way we've been doing for decades. That's since the birth of a database. We've been doing normalization with that approach. I will also say normalization came about because data storage was insanely expensive. We needed to deduplicate the data because it's super expensive to have repeated code. And let me ask you, dear listener, do you think that that's still an issue for us today? I'm going to give you a hint. It is not an issue for us today, right? Like data storage needs or data storage costs have massively decreased. And do you know what has significantly increased? developer costs, right? Like deduping data for the sake of saving storage space is totally ridiculous today. We need to be optimizing for ease of use and performance and scalability. So let's jump into MongoDB schema design. Now that we've covered the basics of RDBMS SQL database design with normalization to the third form. Yes, I see a point about data accuracy and synchronicity. Interesting. So actually, it is for that, right? We're deduping data, which decreases the chances of something going wrong when we're doing updates or deletes. But people forget this. Denormalizing your data is actually not an anti-pattern with RDBMSs. And do you know why we do that? It's because of performance, right? If you have doing joins is insanely expensive for an RDBMS to do. And if we can keep all that data denormalized in a single table with an RDBMS, we get massive performance gains. This is something we've been doing for decades. We have developers have a big hang up about denormalizing data, but that isn't even an anti-pattern with legacy databases. It's not even, it's a standard practice way to increase performance. Okie dokie. So let's see here. MongoDB schema-based design. First of all, there are no pre-prescribed rules. There's no process, and there's no algorithm for doing it, right? Unlike a RDBMS, there's no rules. There's no rules. Okay, no rules. What do we do? Oh my gosh. So how do we do this if there's no rules? Like I said earlier, the number one thing we're concerned with. Let's see here. I got a question over here too. That's a lot to read. I'll get that at the end. No schema. Also, we'll say no schema. Not true. It's a flexible schema. You can actually enforce a schema at a database level with MongoDB, which we'll touch on in just a bit. But no schema is actually not true. But so anyway, when we're designing a schema for our application, the most important thing we can consider is how the data is going to be used by our application. You want to be considered how much it's going to be queried, what's going to be queried, when, and how often. That's the most important thing you can consider when designing a schema for your database. So what is part of that? So when you're considering that, you want to consider how we're storing that data. We want to consider the performance we want to get when querying or doing CRUD operations on our data. And we want to make sure we're doing that with a reasonable amount of hardware. So we have data like this. How would we be using this relational data set we have here, right? We have our user table, which we gave before. I want to quick show how we would be representing this data structure with a MongoDB document. This is a very standard way of storing that user data, right? No problem. You could swap it out for classes or whatever, to-do items, whatever you want to do. But with MongoDB, we want to represent the same data we would with a relational database. What does that look like? So first of all, this user table, it's one-to-one. So we're just going to be saving that data as key value pairs. Not a problem, right? Also, interesting note here too, I will point out specifically, we have our location, geolocation data. That is, we just save that as a tuple, it's a native geolocation data type within BSON that we save in MongoDB documents. The interesting thing is these foreign keys, right? We have the professions and the cars table. Okay, cool. So how do we save that? This is actually way easier, right? As developers, if we were saving these professions as a data type with it, we'd probably be saving that as an array, right? This could be grow to n, size n, or whatever, how many professions a person might have. But we're saving the data, we're using that data as a developer. Okay, what about the cars? Cars have additional metadata, so maybe it makes sense to save an array of objects to save the additional metadata for those cars. Makes sense, right? We're just saving the data. We use that data as developers in a document or an object in memory. Okay. Super fast here. I want to do a quick recap of section 1, relational database design versus MongoDB schema design. So the first thing we discussed today was we started with our foundational perspective of how we do schema design in a relational database or DBMS. We talked about how we normalize to the third form typically. Data is, we don't consider how the data is going to be used when doing data schema design. We only consider what data we have. We're modeling our data independent of the queries we're making. MongoDB schema design is a little bit different, right? There's no rules, there's no process, and no algorithm for it. We want to consider how we're storing that data, and we want to consider what the performance looks like when we get that data. And I'm going to say this again and again and again. If you take nothing else out of this talk, this is what I want you to take, right? You're designing a schema that works for your application. Every application is different and has different needs and requires different data at different points. I want to make sure you're designing your database schema based on the needs of your application. Oh boy. Okay, cool. Any questions so far in the chat? Throw those up there. I'll try to take those if I can. But we got the agenda here. I want to talk again, embedding versus referencing. This is our #1 tool as MongoDB developers for schema design. And the question for us is always, do I want to embed this within the document or should I be referencing this elsewhere? That's what we should be asking ourselves consistently. Great. Okay. So what does that look like? Embedding. Duh. Talked about this. It's an object, right? It's just we're putting the data within a nested object or an array within our document. We're embedding that directly in it. Embedding works like a join in a typical RDBMS. And there's pros and cons to using this. So, pros. If we embed the data within that document, we can retrieve all the data when we need it. A single query, we get all of it. We don't have to do multiple queries to our database to get all the data we need to display. Okay, dokie. We can avoid joins and lookups. Like I mentioned before, doing joins in an RDBMS or relational database is very, very expensive. It's expensive time-wise, it's blocking, and it's expensive for memory. Because if you don't know what's actually happening, what happens is it pulls all those tables into memory, does a join on them, and then it does the query based on the table that it joins in memory. That's slow and expensive. It does not scale well. Same thing with MongoDB. If you can avoid doing joins or lookups on multiple collections or tables, that's going to save you time. Another pro, all the data is there. It's a single atomic operation to update that data if you can embed that within that single document. Okie dokie. Let's see here. Cons. So MongoDB, we have a 16 megabyte per document limit. Large documents have more overhead. They take longer to transfer over the wire, and there's more overhead, like updating, transferring those, right? Typically, I get asked this a lot, like, what if, hey, Joe, I got 16 megabytes of data. I need to save this all in there. Like, for me, honestly, a 16 megabyte document is huge. And it's very big. And we need to start talking about, do we need all that data there? And can we start splitting it up into more reasonable chunks? Can we start splitting that up into reasonable chunks? I got a question over here too. An easy one. Let's see here. Lisanke. I don't know if I'm saying that remotely correctly. You got great questions. I'm going to get those at the end. I'm going to get Felipe's question, though, really quickly, though, just because it's a short one and relevant here. But when should lookup be used? We're going to be talking about that just a second when we talk about referencing. So thank you for that question. Great. Okay, cool. And we mentioned earlier the 16 megabyte per document size limit. Okay, referencing. Let's talk about referencing really quickly too. And we'll discuss the pros and cons. As you probably figured, referencing works similarly to how foreign keys work with joins, right? But what we're doing is we're just linking the object ID of another document to our document in our collection, right? We have an example here of our left-handed smoke shifter from Acme Corp. And maybe we have a bunch of parts. So the question should be here is, why do we need to reference this data instead of directly embedding it? Okay. So let's look at referencing. When should you be doing referencing? Or what are the pros and cons of doing this? So smaller documents, obviously. If you don't have to put all that parts data within that product information, this is a smaller document for us. That's easier to transfer, easier to deal with, and honestly, we don't need it. Less likely to hit that 60 megabyte limit. We're deduping data. Awesome. But this is the most important point personally. When you're designing a schema, you should be thinking to yourself, how are we using this data? So, for example, let's say hypothetically, this schema is for a web application for a e-commerce store. And if you show them, probably the biggest pages is the product detail page, showing all the information about that product, right? I want to know everything about that left-handed smoke shifter, but it's probably less likely or less frequent that all the parts information is required for every single time you access that product detail page. That's why we're referencing it. So if someone requires the information, we can pull that up. But we're thinking about how we're displaying that. If we can get all the data we need to display for the most frequently used information on that page, let's do that. Let's design the schema to do that. And let's put the less frequently accessed data as a reference so we can pull it up if we need it. All right, referencing. Obviously, we have to do multiple queries or lookups in order to retrieve that data. That's going to take longer, right? There's more overhead on that, but we have to take care of that. And that's really the big reason, right? So these are our tools, embedding and referencing. How do we handle both of those? So embedding, but putting the data directly within the document. The same as doing a join, right? All the data is there, retrieves all the data, single query. You don't have to do any joins, and you have a single atomic operation for doing any updates on the application. All right. But you have to worry about the 60 megabyte limit, and you may have additional overhead. If you don't need that data, do you really need to embed it? And referencing. That's using the object IDs to link to separate documents in that collection or another collection to pull that data together. You have smaller documents, you're less likely to hit that 60 megabyte limit. There's less deduplication of your data. And most importantly, in my humble opinion, your infrequently accessed data will not be accessed on every query, right? If you don't need the data, why embed it? Let's wait for it. Depends on how you're using that application. But of course, you're going to have to do additional queries or lookups in order to retrieve all the data you need for the application, which is a performance hit. Okay. This is the last section, but it's the biggest. We're going to be dealing with lots and lots of stuff on here. So, but I want to dig into specific types of queries and specific use cases. And together, I want to try to figure out what's the best schema design for that particular application. So I want to start with the easiest, and then we want to get to the biggest and most complicated. One-to-one. I don't think it's going to be too confusing here, but let's say we just want to add one operation to another one, or one piece of data to another, right? Great example would be my bio I use at the beginning, right? So I just have one person has one company and one Twitter account, right? We prefer using key value pairs. You can use an array with a single thing. That doesn't make sense. Don't do that, you dingus. Just do one-to-one. Just use key value pairs. Duh, right? I'm going to go fast that one. That one's pretty easy. One to few. Same thing. This is where we would do a embed, one to few, right? Maybe it's addresses or the parts or professions or cars you own, right? We would just be saving a few information on it. The key here is that the data is not going to be growing to an unbounded size. It is unlikely for someone to have 30,000 addresses. So I'm going to prefer embedding that data within that. And again, if I don't need this data very often, maybe I do want to reference it. But my first reaction to see something like this is I'm going to embed it. I'm going to embed that data directly in there. Okay, so I mentioned the one to n, right? We don't have an unbounded amount of information. But how do we handle that? Oh, my rules. Yes, I have a bunch of rules. Great. So typically speaking, with MongoDB schema-based design, I'm favoring embedding. And I'm going to embed unless I can verbally state a reason why that's not a great reason. And favor embedding unless you have a good reason not to embed. But let's get into those reasons, right? So, yeah, and needing to access an object on its own is a compelling reason not to embed it. Yeah, if I need to access it on its own or another part of your application just needs it and you don't want the additional overhead of it, great. being able to verbalize that. I think by default, when we come from a normalization background, our default is to split it up. Embed it should be your default with MongoDB. And then pull it into a separate thing if you need to, right? It's the opposite. We're handling that, how we're doing that differently. Okay, so one to n, or one to many. So think we have a product, right, with all these parts on it. How would we be doing that, right? So we have our product and all of our parts objects here. Prefer referencing. Why? Well, I mentioned this earlier. This product might have thousands and millions of different parts on it. That could be huge. And potentially with all the metadata for each of those parts, you could potentially be hitting that limit, that 60 megabyte limit. It'd have to be huge, but it's a thing, right? And chances are you probably don't need all that parts information for every single time you reference it. We do want to keep that data like together, but we can do that via referencing. You can totally do that via referencing. Not a problem at all, right? But think about, do you need that data all at once? Probably not. Prefer referencing it if you have an unbounded or one-to-many relationship with your data. This is kind of related to the rule number one, right? We want to prefer embedding. Because we want to be avoiding joins because they slow down our application. But if it leads to a better schema design, do it. Reference it. Reference that data. That's not a problem. You're going to see performance gains if you can justify having them and splitting that data up. Okay, one of the Squillions. Oh my gosh. Has anyone heard the term Squillions before? I actually hadn't before I actually started working this stack, but I love it. So imagine you're building an application for logs. And no, I don't mean like those kind of logs, like a stump. We don't need those. Imagine you're building a system to monitor your server logs, right? I want to make sure I can monitor my applications in case my servers start burning down. What does it look like? And one is Squillions. So Squillions means I have one server, and potentially I could have an unbounded amount of, I could have millions to billions to trillions of log messages eventually saved up for that one server. Oh my gosh, right? That could get ridiculously really quickly. So how do we handle that? So with the parts, the one-to-many, we did a reference we stored an array of reference object IDs in the product to all the different parts. One to Squillions is a little bit different because if we saved all those log object references in the host, that's an unbounded growth for that array. And if you leave that on with unchecked for years, you're going to hit that limit. So instead, we want to make sure that our documents are going to stay a same size while we're still maintaining that relationship between that server and the log messages. So we do a reverse reference. So you see, we're keeping the object ID of the host saved in the log message. Each log message has the ID of the host saved within it. That way, we do not have to worry about unbounded data being saved within a host and potentially blowing up our document limits. Okie dokie. So we want to prefer referencing, but I want you to make a note here that is a reverse reference. Okay, cool. So rule number 4, arrays should not grow without bound on your application or within your documents. If you do, you want to make sure that you're designing your schema so the unbounded growth will be contained. And we gave the example here by log messages using a reverse reference in order to make sure that we do not hit that, do not have that problem. Okay, here's a fun one, many to many. So let's say hypothetically, you and I were designing a to-do list, and there could be multiple users doing multiple to-do items. And a to-do item can have multiple people working on it, right? This is many. So many users can work on many different to-do items, many to many. How would we design the schema design with MongoDB documents? So let's take a look at this. We have our person documents and our tasks objects. This way we are doing a two-way lookup to maintain that relationship between both of those. So we have an array of tasks per user to keep track of all the tasks that user is doing. But we also keep track of the owners who are responsible for each of the tasks. It's a two-way reference in order to maintain that many-to-many relationship in memory. You can reference both ways. I'm trying to think of anything else to say about it. It shouldn't be too bad, right? You're just doing a two-way reference. It's an additional way to kind of keep track of that information. And you can scale both of those independently of each other. This is the most important rule. Again, I'm going to say this over and over and over again in this talk. The most important thing, right? How you model your data, your schema-based design depends 100% on the needs of your application. Every application is different. Everything you need to display is different. Every application you're querying is different. You need to make sure that you're analyzing how your application works and modeling your data accordingly. And it's because it's the most important way you're going to see scalability and performance gains in your application. Okay, let's do a quick review of and then I'm going to go into the 102 type schema design. So we have 1-to-1, right? Easy peasy. Let's see here. So 1-to-1, prefer key value pairs. That's just using, right? One user has one company, right? Or whatever. 1-to-many, we want to prefer embedding, or excuse me, 1-to-few, we want to prefer embedding. We have our address there, right? 1-to-many, we want to prefer a one-way referencing. Typically, if it's not an unbounded array that could potentially grow at unbounded size, you want to just do a reference by saving the ID reference in the object. This is especially important if you don't need all that part information or that reference data every single time. Reference it. Reference that data. 1-to-Squillions. We gave the example of our logs, right? And how we are using a reverse reference. So if the amount of data is unbounded, we do not want to save that as an embedded array. We want to save the data in each of the log messages and reference back to the host to keep that relationship. Many-to-many, we gave the example of our to-do list, and we're saving the many-to-many relationship by saving a reference to the host or like the person and the to-do item, and we're keeping an array of all the owners for that to-do item and all the tasks owned by that person in each thing. We can maintain that many-to-many relationship. And let's go over those rules one more time. So we had 5 rules we came up with. So we're going to be favoring embedding unless there's a compelling reason not to. If you need to access that own data or the data on its own, that's a compelling reason. Go ahead, right? Pull it into its own thing. Not a problem. You want to avoid joins if we possibly can, right? Embed that data if you possibly can, but it's not a problem if you need to. If you need to do it, if it leads to better schema design, do it. Arrays should not grow without bound. And most importantly, how you model your data depends entirely on your particular application's needs. Okay, cool. I want to go over just a couple of these because I think these are so much fun. And I think they truly start to show the freedom you have with designing a schema with MongoDB or Domain. So this is something called a polymorphic pattern, right? This is a common misconception. All of our documents need to be the same shape in our collections, and they need to have the same fields. They do not. And I'm not saying you don't have a schema. You can still enforce a schema at a database level, but changing the shape of that is not a problem if that fits the needs of your application. Okay, this is my favorite though that I really want to get to. Imagine with me, if you will, that we're building a Twitter-like social media site, right? We have a feed of tweets that are going to be digested by users on that site. How would we design a schema for that application? Well, let's see here. And I want to particularly focus on what this application looks like at scale. So I might have a user like this, and I have a certain amount of followers, and maybe I'm referencing those as embedded followers in there. Honestly, I'd probably argue this is not a good pattern, but let's say we're doing that for this application. And you might see or spot this with me too. The followers could potentially grow at an unbounded size, and that's what I want to focus on here today. All right, what if we get or a Kim Kardashian or a Justin Bieber on our application? What the hell are we going to do? If I got a super celebrity on my brand new Twitter-like social media site, I might freak out just like this. I might lose it. Oh shit, what am I gonna do? Well, with MongoDB, it's actually not too bad, right? And that's actually something we call an outlier pattern. It's actually very similar to how Twitter internally handles outliers like these massive celebrities on the platform. They need to handle how they're distributing their data differently than would a normal user. And one potential way you could do that is with an outlier pattern in here. So I want you to make a note of this. We have our Kim Kardashian user in here. We have the number of followers on there. And instead of keeping an array of all the users she has in there, we have a new key value pair at the very bottom that has extras is true. That notes that this is an outlier in our system, and we need to handle that data differently. And how we might do that is by, once that data gets noted, we can start splitting that data up into overflows for the outliers, right? So you can note here we can start splitting that document up and keeping track of those overflow users into separate documents. Not a problem, right? And you can keep going, splitting that up, sharding it, if you will, right? Splitting that data up as much as we need to. Okay, cool. Oh, yes. All right, cool. So recently, I built a IoT kitty litter box. It keeps track of my cat's bathroom habits and how often the box gets cleaned. All this data is open, but I'm using MongoDB to track my IoT data. I built a chart to show his bathroom habits. This is not it over time, and his cleaning habits. So we can see that as it goes. And I built this using an IoT time series data. MongoDB works really well for time series data, and that's why I used it to design the database schema for it. I also designed my schema based on how I was going to use that data. And how I was going to do that was by by displaying it on a chart, right? And I want to see every day how many times it's going, how many times that box has been cleaned. I'm also keeping track of his weight passively over time, but I want to see that over day to day. I designed my schema to reflect how I was going to be digesting that data. So this is actually how I built that data. You can see here I have some metadata about the box, who it is, who the cat, so my name in it. But you'll see here I have an array of events. It's really unlikely that my cat's going to go to the bathroom more than 30 million times a day. So I'm keeping that as an embedded event in that IoT time series data. And every time he goes to the bathroom or gets cleaned, I keep track of a timestamp and its weight and the event type that happened. You can see here in this day, we keep track of his weight twice. And then I have one maintenance event where I clean his box once in that day. So he went to the bathroom twice, and I'm keeping track of that cleaning event. Okay. But, I want to talk really quickly before I move on here. Is when I was developing this application, I had first only built the weight sensor in the box to keep track of his weight and determine when he's going to the bathroom. But later on, I eventually added a door sensor that could determine when I was actually cleaning that box. You can see that that's the maintenance event on that box. So I was able to update that really easily with MongoDB, right? I had the flexible event thing, and old data I didn't need to update, which you totally can do. You can migrate old data, update it, not a problem. But I didn't really care about it because I'm only displaying like a week's worth of data at a time. So I just decided to add the maintenance data super easily. But this IoT time series schema is a great use case, and it works so well with the document schema design. I just wanted to brag about this. I'm obsessed with this box. I think it's super fun. And I think this is a great use case for using a time series schema. Okay. There's a bunch of other patterns here. I didn't even talk about it. We're still working on these, but there's a great post on it. I have that linked here on the bottom. I also have that reference in my additional resources on that slide deck. you can find out a bunch more of these. These are like the 102 type stuff. So you want to start getting some more interesting scalable patterns besides the ones we talked about today. These are the ones you want to check out. Okay, let's do a quick recap here. So first thing we talked about today was we gave a broad overview of relational schema design, right? The 101, what does the relational database schema design look like? We talked about how you're modeling your data independent of the queries you're using. What data do I have, and how do I normalize this data? And typically, we're normalizing in the third form. Then we discussed MongoDB schema design. We talked about how there's no rules, there's no pre-prescribed process, and there's no algorithm for determining it. The things you want to consider when designing your MongoDB schema design is how you're storing that data and how performant is it going to be when you're doing queries or updates on that data. And most importantly, how you're designing your schema works independently of any other application. It's unique. You want to design a unique schema based on how your application works and how you're going to be using it. We talked about the two basic things you can use when actually doing schema design with MongoDB. That's embedding and referencing. Embedding is obviously just putting that as an embedded document or an array in your document and just saving it there. Referencing is using a ID to another collection or document within that table or that within that collection to pull that data. You do a join or a lookup to pull that data together. You want to prefer embedding when you are retrieving all the data with a single query. You don't have to do any joins, so it's much more performant, and it's all one atomic operation. But you don't want to have too big of a document. You don't have more data than you need for your needs or your application, and you have to worry about that 16 megabyte document limit. Referencing, right? Talk about that quickly. Pros and cons. Pros, smaller documents, less likely to hit that limit, deduping your data, and most importantly, you're not accessing the data you don't need on every single query. Split it up if you do not need it, or you need to access that independently of other data. But you do have to do multiple joins if you do need all that data eventually. Okie dokie. Types of relationships, one-to-one, using key value pairs, easy peasy, one-to-few. We're going to prefer embedding, right? Unless you don't need that, but like we want to prefer embedding with an application. One-to-many, that means you have lots of parts on there. You especially want to do referencing if you do not need all that data every single time. In this example, we probably don't need all the parts information every single time we query an object in our database. One to Squillions, we gave an example of our logs, and we do a reverse reference so we can avoid unbounded array growth. We have the many-to-many with our to-do list. One to-do item can have many users, and one user can have many to-do items. We're doing a two-way referencing in order to keep track of that relationship. And we discussed 5 rules of MongoDB schema design. We want to favor embedding unless you have a compelling reason not to embed. Needing to access that object on its own is, in fact, a compelling reason not to embed it. Joins are expensive regardless of the database you're using. So if you can be avoided, great, do it. Arrays should not grow with outbound. That is a huge red flag and bad code smell with schema design. And most importantly, model your data depending on the needs of your unique application. How are you going to be using it? And what kind of query performance do you need from that application? Okie dokie. Let's see here. I got a bunch of questions here. I'm going to try to do these. Taking a look at the questions over here. Actually, you know what? I'm going to finish this out here really fast, and then we'll do the questions. If you want to learn more about MongoDB, we have a free online university. If you go to university.mongodb.com, I highly recommend you take the M320 course. That's a data modeling course. It goes more in depth in the information we talked about here today. If you're brand new to MongoDB, there's an M001 course, MongoDB Basics. I highly recommend taking 2 if you just want to get started with MongoDB. Most importantly, though, if you want to learn more about MongoDB or just in general about anything, just go and do it, right? If you want to learn more about a database that you hear about today, go home and on your next side project, try the database out, play around with it, see what you can do with it. I try to do a new piece of tech on every project I do in order to get better at it. I want to be constantly learning and expanding my skill set into new tools and frameworks. But I try to build that all the time. But if you're interested, try to do it, right? You can take those courses, but personally, the way I learn, I just go and try to build it out on my own. So also, if you want $100 in free Atlas credits, that's our online hosted MongoDB database as a service. You can use JokeK100 or use that QR code All the information is there on there for you. There's additional resources. These are all linked in my website. I linked on there. I'll link that down again for you. But if you use that QR code, that should take you there. And here's me again. Again, Twitter is the best way to reach out to me if you want to get a hold of me. And the links to all the resources are at that bit.ly link or that QR code on that page. I'm going to post this in the chat one more time. And then I'm going to start doing questions. Okay, copy pasta. There we go. Just linked all of those questions again. Okay, let's see here. Got so many good questions. Okay. Someone split their data up into similar. So one of the questions about why is there a 16 megabyte limit per document? I'm not sure the technical reasons, but I do know it's enforced just for like performance and scalability. I think that the other thing too has to do with keeping documents in RAM, in memory as they're being written. So the trade-off you have to make then too is you have large documents, you have fewer. The RAM can hold less documents in memory and have less room to work with. It's expensive. There's a 16 megabyte limit on it. Again, like I said, if you do have a 16 megabyte document, which happens a lot, I honestly hear that use case a lot because we're used to working with massive amounts of data. But what you need to do is start figuring out how you're actually going to be using that data and figuring out how we can split that data up and doing referencing in order to make it more usable and scalable with our application. Because chances are, most of the time when we get into it, it's very rare we need to have all the data together all the time. If we can start splitting it up and doing referencing, that tends to be a better pattern for accessing that data. Okay. I got a question about UUIDs with MongoDB. So someone trying to use their own custom foreign keys or unique IDs. I get this a lot too. And I honestly understand the impulse. Like, hey, we have, like, for example, the Twitter application. Every user has their own unique Twitter ID. Let's use that as our unique ID. That actually, it tends to be a really bad idea. And I've never ever recommended obliterating your foreign keys. The problem happens at scale. So the second you start sharding and splitting up your data, then you start getting the massive issues of scalability. So like you have two different clusters who are like sharded clusters doing operations independently of each other, and you have unique IDs, you have a much higher chance of getting a collision or repeated data. What I recommend is preserving the unique UUID generated by MongoDB and putting a new key value pair with that unique key that you actually want to have it on there. You never obliterate it. Also, I'm just going to say this too, generally speaking, never ever use incrementing unique IDs ever. It does not scale well, and it actually gets really complicated really fast. And it makes sense for our tiny, puny human brains, but for computers, it's a disaster, and especially in a distributed system, it never works well. You will have a bad time. Updating and scaling is massively challenging with that. No, but Twitter guarantees no one could ever guarantee it's unique. No. They do, but think about this. What if someone deletes their user ID, or changes it, or goes back and goes through? There's so many problems that you have to consider. And if someone tells you it's an enforced UUID, it is not. Even if it is not, there's always a chance for collision. It has a very small chance for collision, but it does not. Also, you lack flexibility with your applications too. Okay, we're getting a lot of things here. Okay. We got a bunch of people here trying to read questions. How do you manage data replication? I'm not sure what that means. What do you mean data replication? I mean, so you have documents within there with repeated data. The same way you would handle that with normalized data in a relational database, right? You have the same thing. So you just want to make sure that you are handling the data that you get, and you want to make sure you're updating all that data too. And you have to do that with a denormalized data set with a relational database too. You're just making sure you're updating all the previous records. Looks like we're getting rated. It's hard. Let's see here. Let's see. Hard to keep track of all the questions. Looks like there's a lot of stuff going on. Cool. Welcome, everybody, coming in. This is great. So let's see here. What types of reporting tools do I use against my data store? What do you use for pre-processing for reporting? It depends. Honestly, I dog food everything. So I typically do pre-processing in the driver of my choice. And if I don't need it, I won't use it. But looks like there's a lot of stuff going on here, which is great. Yeah, I'll do reporting or pre-processing with the driver. So I need to clean data up or do updates on it. I'll typically do that with whatever language, primary language of choice. I'm a Node.js developer. I typically do that. Python's also a great use case for that too. But we also have like charts that you can also use with MongoDB, which I think is really great and super easy to use. Okay, let's see here. Any other questions? I'm reading through these. There's just a lot of stuff to go through. So one of the questions about Postgres versus with the JSON storage, column storage. Yeah, so flexibility with the data. The other one too is indexing internal data. MongoDB honestly is much better indexing embedded data within it. And it's more native to it too. And I agree, Postgres can handle it really, really well, but MongoDB could do everything a PostgreSQL server can do. It's a good general purpose use case for it these days. Okay, I don't know. I think that's about it. Let's see here. Kevin, I think I'm probably good here. Oh, let's see, I got one more question, and then I'll wrap it up here. Let's see here. OLTP work with the system. I don't know what that means. OLTP.
Online transactional processing.
Let's see here. I'm doing my processing on the edge. So for that, my IoT thing I showed you, the IoT kitty litter box, that is I'm doing all of the pre-processing on the edge with a Raspberry Pi, which I think we're seeing more of these days as well. Especially as IoT chips get more and more powerful, I think doing pre-processing is fine too. But traditionally what happens is send that raw data to a cloud, and that'll be managed. They'll be processed on a large server in the cloud somewhere. That's traditionally how they're done. I think edge computing is becoming more and more popular though with our IoT data.
All right. So that looks like that was all of the questions. If you do have follow-up questions, feel free to reach out to Joe on Twitter.
Yes, please. Yes, that's the preferred way. Love that.
Within 280 characters.
Yes. Or you can DM me too.
Wonderful. So with that, we're going to go to intermission. We'll be back in about 7 minutes with our next presenter. So everybody hang tight. I am going to stop the stream for just a few seconds to switch title, switch everything, make life easier for me later on. And with that, we'll be back very shortly.